So we are mainly having this is the first topic. This is a continuous topic, first one. Then we are having this is a second one. Then third one. Okay, so this can be again this can be third one and fourth. So there are 4 topics to be covered in this module. So first one will be the stresses in inclined sections for uniaxial and biaxial stress fields, to find out the principal stress, what is one the principal stress, principal planes, maximum shear stress, then strain, then the Morse circle. So these are things which we will be discussing today, and then other 4. So this module can be divided into 4. That is module 1, 2, the topic module 5 can be divided into 4 parts. Module 1, 2, 3, and the topic 1, 2, 3, and 4. So here So the first topic is on member subjected to direct stress in one plane. That is, here we have to discuss. So let us consider a figure. That is 4 conditions we have to study. A body which is subjected to a single stress. That is, this is a tensile stress. It can be compression. This is the first condition. Second condition, it is a body which is subjected to stresses along both the directions. This is the second one. Third one is that this body is having stresses in both the directions along with the shear stress. That is the third one. And the fourth one is that a body which is having only shear stress. Okay, so here mainly we have to study these 4 conditions. In these 4 conditions we will be considering, so let us take, so first condition is given here, that is a body is here, it is acting, a force of peak units is acting as shown in the figure, that is in one side it is acting, so it is along the longitudinal side it is acting. So P is the axial force. So this is the first condition we are going to study. Now let us consider a section GF. So mainly we are going to find out the forces at a section, that is at a section which is at an angle theta. So if here the force is P. Now if I am considering a section GF at an angle which is inclined at an angle theta like this, then at this section, due to this force, there can be 2 forces. Okay, this is an inclined section. So this inclined section will be having 2 forces. One force is a normal force. Other force is a tangential force. Okay, so a single, when we are considering, so this there can be 2 forces. One is a normal force, other one is a tangential force. So that is shown here, P, N and P. So in every problems which we are going to study, there are 4 cases, and in all the problems here we are going to find out these values of normal stress, normal force and tangential force or shear force. So for example, you just consider here the stress, that is I am considering a section EF. You can see EF is perpendicular to this force P. Then we all know what is stress. Stress is equal to force by area. That is perpendicular. The force is P divided by area. So here what area of EF is? Considering a EF which is having consider a cross section EF which is perpendicular to the line of action of the force P. Now here sigma is equal to force by area. So P by A. So the stress on this section EF is entirely, so at this section the EF will be having a stress. That stress is equal to force by area. So area will be again if I am considering this section, this is EF into a single length. So let the area be A. So this is the stress at this direction. Now let us consider the stress on Fg. So now I am going to find out the stress on Fg. That is, Fg, it is inclined at an angle theta. So stress on Fg is equal to force by area of Fg. Force is again P divided by area. Area of Fg means Fg into 1 unit width I am considering. Now instead of Fg, you can see this triangle. I am converting this Fg into EF term. So if I am taking cos theta of this angle, what is cos theta? Cos theta will be EF by Fg. So instead of Fg, I can substitute EF by cos theta. So this will be the area of EF. So P by area of Fg, that is A by cos theta, or that is equal to P by A cos theta. That is P by A can be written as sigma cos. This is the stress at Fg. This is the stress at Fg. Now, so stress at Fg is equal to sigma cos theta. Now, the normal stress. So again I have said that there in this condition there can be two forces. So any section. So here if you are considering this section, this area, there is only one force. But if I am taking an inclined section at an angle theta, due to this stress, there can be two stresses. One is normal stress, and other is shear stress. Here Pn means the load only. So Pn means load. Pt is the shear load or the tangential load. Corresponding to that, normal if I am having a load, there will be a stress also. So that values, if I have that is normal stress is equal to normal force divided by area of the section Fg. So normal force is here you can see that here I am drawing the figure. Here P is acting. Okay, P is acting. Now here I am considering a section at an angle theta. Now this is the force. P, it is a force. Now what will be the normal? That is, here you can see. So here you can see that P, it is acting like this. Okay, P is acting like this. I am going to find the value of Pn and F, or this is a normal force, or we can write it as sigma, normal stress, or here also shear stress or tangential stress. Both the wordings are same, shear stress or tangential stress. So here if this is theta, again this angle will be 90 minus theta. So this can be 90 minus theta. So this is theta. So what is the normal force? That is, this is theta. So this component will be P cos theta. So again I can write like this. So here I can be writing normal. So normal stress is equal to P normal force divided by area. So P cos theta divided by area is, area of Fg is, we have found it as A by cos theta last year. So what is the answer? That is P cos theta. So I can into the cos theta can be taken to the top side. So how can I write that? That is P into P by A into cos square theta. What is P by A? That is sigma. So this is the normal stress at that section Fg. Now the shear stress, again shear stress will be P sin theta. How the sin theta term is arrived? Here you can see that. So here this is P. So this if it is theta, how can I write this is the component? So this can be converted. This is the parallel terms. Therefore, the other component will be P sin theta. One will be P cos theta, and the other component will be P sin theta. So you can see that. So I am substituting P sin theta divided by area. Area is again A by cos theta. Therefore, by substituting this, you can see that P by A into sin theta into cos theta. But so again sigma sin theta into cos theta. Okay. Now I am dividing and multiplying by 2. That is sigma by 2 into, here the same term, dividing and multiplying by 2. We know that 2 sin theta cos theta is sin 2 theta. Okay. Here I am having sin theta into cos theta. If I am multiplying by 2, it will be becoming 2 sin theta cos theta. What is 2 sin theta cos theta? It is sin 2 theta. Therefore, I got the value as sigma by 2 sin 2 theta. So you can see that in this figure, so this is our first condition only. So in this figure, you can see that it is Pn and Pt. So what is the value? So it can be sigma n. Pn is the force, normal force. Sigma n is the normal stress. Pt is the tangential stress, and sigma t is the tangential stress. So sigma n we obtained as what is the value of sigma n? The sigma n is equal to sigma square cos square theta, and here it is sigma by 2 sin 2 theta. Okay, so while doing a problem it will be more easy. Now here you can see that from the equation 2 point, it is seen that the normal stress is sigma n on the section will be maximum. What is the maximum value? So this condition can be maximum. This will be maximum when cos square theta is equal to 1. Okay, so this term can be maximum when cos square theta is maximum. So cos theta will be maximum when theta is equal to 0. But when theta is equal to 0, Fg will be coinciding. That means the maximum stress, normal stress is equal to sigma. That is the maximum normal stress which can happen. Now again, the maximum shear stress. So this is the value of shear stress. The maximum shear stress will be sigma by 2 sin 2 theta is maximum when sin 2 theta is maximum. So sin 2 theta is maximum means sin 2 theta is equal to 1. That is 2 theta is equal to when it will be 1. That is when theta is equal to 90 or 270. So when 2 theta is equal to 90 or 270, the tangential stress can be maximum. So what is the value? That is 2 theta is equal to 90 or 270. So the theta will be 45 and 1. So at 45 degree and 135 degree, the tangential stress will be maximum. So here you can see in the figure, that is here when theta is equal to 45, there can be a maximum, and theta is equal to 135, there also can be maximum. Now the maximum value of the shear stress is equal to sigma by 2 sin 2 theta. So this is equal to 1. That will be the maximum value of shear stress. Okay. Now just we can consider just a problem. So simple problems only here will be asking. You can see that a rectangular bar of cross section area, a bar is given, is subject to an axial load of 20 kilonewton. So here I am having a rectangular bar. It is acted upon by an axial load of 20 kilonewton. 20 kilonewton like this. Determine the normal stress, shear stress, which is inclined at an angle 30 degree with the normal cross section of the bar. Which is inclined at an angle 30 degree with the normal cross section of the bar. What is a normal cross section? This is the normal cross section. Okay. So this is a normal cross section. So we have to find out the shear stress at determine the shear stress at a section like this, that is inclined at an angle 30 degree. So the important thing you have to understand while doing this problem is that the angle, this theta, you have to understand. So theta is always taken like this. From this direction only it is taken. Okay. So sometimes you will be given this angle. So in that case, what will be the theta? It will be 90 minus that angle. So that you have to keep in mind while doing the problem. That is the only thing that you have to, main thing you have to keep in mind. So here again, what will be the normal stress? Normal stress is equal to sigma cos square theta. Theta is 30 degree. So you can directly find out the answer. What will be the shear stress? It is sigma by 2 sin 2 theta. That is, theta is 30. So from these, this is the normal stress and this is the shear stress. Okay. Now again another question. Here it is given that here a rectangular bar of cross section 110 is subject to a tensile load as shown in the figure. The permissible normal and shear stress at a plane BC, it is given. Here the normal stress is given. Sigma n is given as 7 Newton per mm square and sigma t is given as 3.5 Newton. So here I have to find P. So first thing is that you just understand this is 60 degrees. So which is the angle which you have to take? This is the angle. So what will be the angle? It will be 90 minus 60. So that is theta. So now we have sigma n is directly given. What is sigma n? Sigma n is equal to sigma cos square theta. That is equal to 7. So in this theta is 90. We can find sigma. So sigma one value we obtained as 9.334. Again, it is again given in the question that sigma t is also given. That is 3.5. So again I can find one more sigma. So here you can see that one answer of sigma is 9.334. Another answer of sigma is 8.08. So the least of the value will be the permissible one. Therefore, sigma we can take it as 8.083. So this is the value. So the safe value of we have to find P. P will be, this is stress. That stress into the area. Area of cross section is directly given in the figure. In the question itself, it is given 11,000 millimeters square. So from that we can find out. Okay. Now another question is given here. Okay, that's it. So that is a value. So that's the same question only. So this is the way in which we will be doing the first set of problem. Now only thing is that how this values you have to understand. So this is a simplest case. So sigma n is equal to sigma cos square theta. So this is the first thing. So three values you have to understand. One is sigma n, then is sigma t, and the resultant. What will be the resultant? Resultant will be sigma square plus sigma t square. That will be the resultant. Okay. So these are the things you have to keep in mind. Now let us take the next condition, that is here. Here you can see that a member is subjected to direct stress in two mutually perpendicular directions. The first condition, what was the condition? That is only one load was there, only in one direction. Here, next condition, two sides there is load. Okay, that is in the x as well as in the y direction we are having the load. X and y direction we are having the load. So here, let us take, so here you can see, here also load is there and here. So what is the changes that is going to happen? So here we are having two theta. Theta you can hear, what is the theta taken? Theta is, this is the section which we are going to consider. CF is the section. Theta is the angle made by the section with the normal cross section of BC. So this is BC and this is theta. Okay. So that is the theta we are going to take. Now sigma 1, it is a stress. It is taken as major because in this question we are taking a sigma 1 is greater than sigma 2. Okay. Now P1 is the force along, so two forces are there, P1 and P2. So similarly there is sigma 1 and sigma 2. Okay. So here the change is that while calculating, so same way only we will be finding out the sigma n. Here the value of sigma n we will be getting like this. Sigma n is equal to sigma 1 plus sigma 2 divided by 2 plus sigma 1 minus sigma 2 divided by 2 into cos 2 theta. So this is the value we have to understand. But in the last condition, what was the value? Sigma n is equal to sigma, what was the value? Sigma cos square theta. So in the first condition, the value was sigma cos square theta and sigma t was sigma by 2 sin 2 theta. So this was the value. Now this sigma n, but here there is two sigmas. So what is the value we are obtaining? Sigma 1 plus sigma by 2 in plus sigma 1 minus sigma by 2 into cos 2 theta. And sigma t is again, you can see that it is, the value is sigma 1 minus sigma by 2 sin 2 theta. Okay, the last condition what it was? sigma by 2 into sine 2 theta. Here the sigma by 2 is changed to sigma 1 minus sigma 2 by 2. Okay, negative sign is coming. So that is the change. So these equations you have to keep in mind. Now you can again see that another condition is that here this is the normal stress that is coming here. This is the tangential stress, okay, that I am marking in red. Now the resultant will be like this in the green portion. So we have to you may have studied in your maths and in many other subjects, that is we have to find out what is the resultant making, what is the angle that is made by the resultant. So that angle here I am taking it as here you can see this is taken as, this angle is taken as phi. Okay, this angle is taken as phi. So how can I find out phi? Phi will be tan phi. So tan phi is equal to sigma t by sigma n. Okay. Now again, likewise in the same problem, the maximum value of shear stress, that is sigma t will be maximum when sine 2 theta is equal to 1. Sine 2 theta is equal to 1 means theta 2 theta is equal to 90 or 270. Therefore, theta can be 45 or 135. The same thing which we have done in the other question. The same thing is been here. So here at 45 degree and at 135 degree, the shear stress to sigma t will be maximum. Okay. And again the principal, here you can see another term is coming, principal plane. So what is principal plane? Principal planes are the planes on which the shear stress is 0. Shear stress is 0 means what is? Sigma t is equal to 0. The relevance of these topics, after taking this topic, I will, why we are finding out, I will explain that, because we are given a small body like this, then force is acting in different directions. Now what we are doing, we are finding the shear stress at some plane, some angle. So what is this is mainly done. For example, when we are loading a beam is loaded like this. Then if you have to find a shear stress at some angle, so that is the application of this type of problem. So this is here we are only using some tools to understand how we can find out this values. So that is the practical application that we will take up as the topic is going on. I will explain on that. So now principal plane. So what is principal plane? Principal plane means sigma t is equal to 0. But we now know that what is the value sigma t is sigma 1 minus sigma 2 divided by 2 into sine 2. This is 0. So this term, there are two terms. Here sigma 1 minus sigma 2 cannot be 0. That is the important thing. So only condition is sine 2 theta can be 0. That is sine theta is 0. When sine theta is 0? When theta is equal to 0 and 180. So 2 theta is equal to 0 and 190. Therefore theta can be 0 and 90. So at 0 degree and 90 degree, it is the principal plane. Okay. So at theta is equal to 0, if I am substituting sigma n, what will be sigma n? It will be sigma 1. And at theta is equal to 90, sigma n will be sigma 2. Okay. That is, you can just understand here. This is the values, sigma 1, sigma 2. This is sigma 1, this is sigma 2, and this is sigma 2. So when theta is equal to 90, theta is equal to 0, that is, this is the line. Here sigma n will be sigma 1 only. When it is 90, what will be? Sigma n will be sigma 2 only. So saying that we don't have to derive these things, because just from the figure itself it is clear. Okay. Now let us, in the same problem, likewise we have done, another problem is given. So a tensile stress at a point of cross section of two mutually perpendicular planes are 120 and 60. So I am given a bar is given, and the stresses are given like this. So this is a stress, that is a 120. Here it is also 120. Here 60 and 60. So first thing is that now find out the normal stress tangential stress and resultant stress on a plane inclined at 30 degree to the axis of the minus stress. Okay, 30 degree to the axis of the minus stress I have to find out. So here, now here theta, what is theta? Here which angle I have to take? Now here, if I am considering from the figure, okay, so just understand, this is the angle theta I am considering. So that theta means here this tan theta is the angle axis inclined at theta to the axis of the minus stress. So what is the minus stress? Here 120 is there, 60 degree is there. So here this is the minus stress line and this is the major stress line. Again I will mark in another color. This is so theta means, if this is the line, so this is the minus stress line. So this is theta, or from this line if I am taking, this is theta. So that is the angle you have to take. So I can substitute in the figure. Sigma n is equal to this you have to by heart, that is sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma by 2 into cos 2 theta. Okay, by substituting all this theta is 30. We will be getting sigma n. Again, what is sigma t? Again we have the equation. The sigma t is equal to sigma 1 minus sigma 2 by 2 into sin 2 theta. Okay, and what will be the resultant? The resultant will be a root of sigma n plus n the whole square plus sigma t the whole square. So here it is clearly drawn. Here the angle we are taking, it is this angle. The same thing only I have drawn. This angle, this is the angle, this angle and this angle will be the same. So in another problem, if you are looking, here you can see there is a change, that is here the same problem only. Here we are having two forces, that is 200 kilonewton and 100 Newton. And another change is that this 100 Newton is compressive. Okay, while these equations are for tensile forces only. Now the condition is that one is tensile and other is compressive. So the change is that sigma 1 is 200 and sigma 2 you have to take as minus 100. Okay, now here what is the angle? This angle to the major axis is 60 degree. So you can see that this is the major axis. This is the major axis. So that is making an angle 60. So which is the angle we have to take? With the minor axis only we have to take. So this is theta. So this one you have to clearly understand what is the angle. The only mistake can make is here. So this is 60. That is with the major axis. So which is the theta? Theta means which is the minor axis. So it will be 90 minus 60, that is 30 again. So again by substituting, the only change is that instead of sigma 2 we have to take a minus term also, because it is compressive. So in the same way we can find out here what are the you can see that here we are finding out the we have to find out the magnitude of resultant stress, also the maximum intensity of shear stress. Shear stress also we have to find out. So the resultant stress is again same that of the other way. Sigma n we have to find out, sigma t I have to find out by using these equations. From that I can find out what is the value of the resultant stress. And what is the value of maximum shear stress? Maximum shear stress is given by the equation sigma t max is equal to sigma 1 minus sigma 2 divided by 2. So what is sigma 1? It is 200. 200 minus what is sigma 2? It is having a negative sign. divided by 2. That is, it will be 300 by 2. That will be 150. Okay. So by this way, we can do that problem. Again, another problem is also given here. Only change is that the angle. You have to keep in mind what is the angle, and we have to find out the problems. Okay. Okay, I think so. That is a second condition. Okay, some problems are given. You can just look at the problems, and either you have to take positive or either you have to do negative. Likewise, you can finish the equations and find out the answers. The next two conditions we have to study is that here you can see here, along with the sigma 1, sigma 2, I am having a shear force also, shear stress, that is shown here. Shear stress is always shown like this. You can just understand this is the shear stress. Okay, that is the shear stress. So if that shear stress is coming, some change in the formula will be there. Here you can see only some change is there. That is sigma n is equal to this much was the same thing which we have studied. Sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma by 2 into cos 2 theta. And another term is there. What is that? It is the shear due to shear. Tau sin 2 theta. Again that is coming. And similarly in the sigma t also. In the last problem, it was only up to this one. Again, minus tau cos 2 theta term is coming. Okay. So, in the first condition, that is the first condition, what it was, only one stress was there. In that condition, what was sigma? Sigma is equal to sigma cos square theta. This was the first condition. And sigma t is equal to sigma by 2 sin 2 theta. Again, in the next condition, what happened? There are two stresses in the both directions. Then again that sigma n increased to sigma 1 plus sigma 2 by 2 plus sigma 1 minus sigma by 2 again. And in the third condition, another term is also coming, that is tau. So likewise only this problem will be, this conditions will be expanding. So from the first stage, only 4 conditions you have to study, and the only change is that when a shear stress is coming, another term will be also there. Okay, so that we will discuss the next class. So okay.